Hi and welcome to this video on chemicals in our lives, and today we're going to be looking at water and chlorination. So four major water resources are things like lakes, rivers, reservoirs and aquifers, so an underground source of water. And so it raises the question, would you drink water straight from the river? And potentially not, and the reason being is there are a number of different things found within water that you find in rivers or lakes before it's been purified and before it's been had a lot of the nasty things taken out of it. And when you consider that a lot of people around the world, so over 1 billion people don't have access to safe water, so that's 1 in 7 or over 1 in 7, and that nearly 2.6 billion, so we're looking at about a third, don't have access to sanitation, so that's basically a clean environment, somewhere to go to the toilet, and 1.8 million children die every year through dirty water. And so it's a massive problem in the world, and obviously not a problem affected by us in the West, or particularly within Britain. And when you consider, if you look at these figures, that an average European would use 200 litres, a North American 400, and someone in the developing world, so this can be in parts of Africa and Asia, only have access to 10 litres of water a day, you can start to understand about the inequalities that we have around the globe. And so back in around the mid-1800s, John Snow, a prominent physician at the time, identified a disease called cholera, and he narrowed it down to being a waterborne infection. And he was looking at the rates of cholera, particularly, and he noticed that around the water pumps, so where people got water from, he was noticing that there were more cases of cholera. And so he obviously made the link between cholera and being carried in water. And so within river water or lake water, you can find some of the following things. So dissolved salts and minerals, so those are things like the salt that we get in the sea, so sodium chloride, or it could be calcium, for instance, as a mineral. You've got microbes, so microorganisms living in there. You've got certain pollutants that live in there, and some insoluble materials, so things like very, very small, fine grains or sand, for instance. Now within water purification, and so when you have a pure substance that only contains one thing, and the three major processes in purification, one are sedimentation and filtration, and they're very, very similar. So sedimentation removes large insoluble material, so this could be large stones or sediment. Filtration removes smaller insoluble material, so much, much finer insoluble material. And then finally, once you've got everything out that can be filtered out, you can undergo the process of chlorination. And chlorination means to add chlorine to the water, and because chlorine has kind of antiseptic qualities, it can actually kill off microbes that might otherwise cause disease. And so when we've undergone chlorination programs, what we've actually done is we've reduced the spread of diseases like cholera and another called typhoid. Now this shows some of the purification processes of the water that we have. So we can take the water from, say, a reservoir or from a lake or river, and it can go through a number of these stages. Now obviously for the exam you don't need to know these, but what you do need to know is the fact that obviously you're going to remove large rocks or sediment, and you're then going to filter out some of the smaller, finer grains, and again that's a type of filtration. And then at the final step you're going to add chlorine, and this chlorine can then destroy any of the microbes that are in there, and therefore we get safe and clean drinking water. This can then be sent to a surface reservoir and then can be sent out to homes that's safe for consumption. And so we don't have the issues in some other parts of the world because the water that we get to our homes is clean. So a disease that's actually carried in water is called typhoid. And you can see from this graph that what we've got here is along the x-axis we've got time, so running from the 1900s to 1960s, and at the side, or the y-axis here, we have the death rate per 100,000 of the population. And if we think about that for a second, the death rate per 100,000 of the population, if you think about what that actually means, it's giving a relative value of an amount of people that died for every 100,000 people within the population. So rather than giving the overall number of people that died, we can give this value per 100,000, as it makes it easier to compare with. And so it takes into account if the population has changed. So for instance, in the 1900s, the population might have been very, very small, whereas later on in the 1920s, the population might have grown. And so if you just reported the number of deaths, because the population might be much, much higher in 1920, what you in fact might report is the number of deaths might have been similar even after the chlorination had begun. And so we put chlorine in to kill off the typhoid bacteria. Now, in 1920, with a big population, there might still have been quite a number of deaths, but if you put it per 100,000, it enables an easy comparison. And we can see from this graph, if we were asked to describe this graph, we would say something along the lines of before chlorination, the amount of deaths per 100,000 dropped and then raised up back to their original levels and then began to drop again. But if we were to describe after chlorination had begun, we can see that there's on average a steady decrease in the number of deaths per 100,000 down to a point at which there were no deaths around the late 1940s. Now, looking at this data, it does seem very compelling evidence to suggest that the chlorination had basically reduced or it had definitely had some influence over the death rate. But from this graph, we can't tell whether there's been any other intervention. So stuff like the medicine used to treat typhoid fever might have got better in that period of time, and so might have had an influence over the number of deaths. We can make, the conclusions we can draw from this is it would appear there's a correlation between when the water was chlorinated and the number of deaths dropping. But what we can't say for definite is that definitely chlorination had actually caused this change. It suggests it, which means a correlation, but we can't get causation from it. But if we look at the death rate even after around 10 years after chlorination began, it was still relatively high and hadn't dropped to zero. And there might be a few reasons for this. Things like the people who had the typhoid or were dying of typhoid might have had the infection prior to chlorination. That could be a potential explanation. Or the fact that not all of the water had been chlorinated at this point, so people were still drinking contaminated water. So common exam questions, particularly to do with graphs on this, might ask you to describe the relationship between chlorination and the death rate of typhoid fever, and this is where you'd quote the overall trend, so you would say something along the lines of as time went on, the level of death rate went down after chlorination had begun, something as simple as that, and then quote some numbers from the graph. Explain the role of chlorination in reducing death rate. This is where you talk about how chlorine is antiseptic, so it can destroy microbes that carry the disease typhoid, and therefore the level of deaths went down. And another question might be evaluate the role of or the use of chlorine in treating typhoid. And so evaluate means for you to give the positives and the negatives. And so in this case, the positives would clearly be, obviously, after chlorination, the numbers dropped to zero up to around 1948. And the negatives for this is they didn't drop instantly. And so this may suggest that it wasn't 100% effective. Now, there are possible disadvantages of using chlorination. There is research to suggest that when adding or undergoing chlorination, then you can produce these chemicals called DBPs. Now, you're not expected to remember that name, but the types of risks we're talking about are things like increased rates of cancers, and so obviously when they react with organic material, this could lead to things like cancers. And also there's some research which suggests there is a link between these chemicals and people having reproductive issues. But in the main, most of the research suggests that the risks involved with chlorination are very, very small, and the evidence for it is not particularly strong. And so that's why we still undergo chlorination, because obviously the benefits and the evidence shows that it's not actually that dangerous.